Welcome back, everyone. Today, we're diving into a topic that I know a lot of you have been asking about free will.
Oh, yeah. It's one of those big questions, isn't it? The kind that's been debated for centuries.
Exactly. And we're going to try to unpack it by looking at Chapter 12 of our source material. Is this free will?
It's a really interesting approach, actually, because they start by tracing the evolution of agency. Like, how did we even get to a point where we could ask the question of free will in the first place?
Right. Like, how did those simple life forms billions of years ago evolve into beings capable of making choices? And what does that journey tell us about our own capacity for free will?
Well, and they don't shy away from the big implications either. Like, what does it mean for morality, for responsibility, even for our legal system?
It's a lot to cover, but I think it'll be a fascinating discussion.
Yeah.
So to kick things off, let's rewind the clock way back to the very beginning. For billions of years, the universe was pretty much inactive. Then, life emerges, and with life comes action. It seems straightforward, but what does that shift really signify?
I think it's actually a monumental shift. Because for life to exist, it has to persist, right?
Oh, I see what you mean. It can't just be, it has to actively keep on being.
Exactly. Even the simplest organisms have this inherent drive to maintain their own existence. And that's where agency begins, in that drive.
So it's less about existing and more about actively working to keep existing.
Precisely. It's about self-organization and the constant effort to maintain that organization against a world that's always trying to, disrupt it.
Yeah, it's like swimming against the current, in a way.
Exactly. And a great example of this is a single-celled organism. Like, it has a cell membrane that acts as a shield, right? It allows the organism to be selective about what it interacts with.
So even at this really basic level, there's a choice being made.
Oh, absolutely. These organisms, they're not just passively floating around. They're dynamic processes constantly working to maintain themselves.
So they're not static machines. They're more like, I don't know, tiny little factories constantly humming with activity.
That's a great analogy. They're actively engaged in shaping their own fate, even if it's on a microscopic scale.
It's fascinating to think about it that way. So we've got these early life forms actively striving to survive. How did they evolve into more complex agents, making choices and taking actions?
Well, over vast stretches of time, evolution favored organisms that developed new abilities.
Like what?
Well, movement, for instance, was a game changer.
Because it allows an organism to move towards things that are beneficial and away from things that could be harmful.
Precisely. But it also created this need for information. Organisms needed to know where to move, which is where sensory systems come into play.
Ah, so the senses evolved as a way to guide movement.
Exactly. It's like a feedback loop. Sensing guides movement, movement leads to new sensory input, and so on.
So this is where you start to see a kind of directed action driven by a purpose, even if that purpose is just survival at this point.
Exactly. Even simple behaviors like approaching food or avoiding danger represent early forms of meaning and value.
Because they're directly tied to that fundamental goal of survival. But here's a question. Are they really making choices at this point? Or are they just responding to stimuli in a pre-programmed way? Like, is there a difference?
That's a great question, and it gets to the heart of what agency really means. It's easy to think of these early organisms as simple stimulus response machines. But even single-celled organisms, they can integrate multiple signals, and then, they generate sophisticated responses.
Based on both their internal state and what's going on in the world around them.
Exactly.
Do you have an example?
Yeah, sure. Imagine a single-celled organism navigating its environment. It might be sensing, let's say, the presence of food, changes in temperature, even the presence of other organisms.
Some helpful, some harmful, right?
Right. All this information is being processed simultaneously.
Yeah.
And its response, it's not just a knee-jerk reaction to one specific stimulus. It's more like a complex calculation.
It takes into account multiple factors.
Yeah. And it results in a coordinated, almost purposeful action.
So even at this early stage, there's a level of agency beyond a simple input-output system.
Exactly. It's not just about reacting. It's about integrating information and choosing a course of action based on that integration.
That's really interesting. And as we move up the evolutionary ladder, this complexity, it just keeps increasing, right?
Oh, absolutely. And the emergence of multicellular organisms, well, that was a huge leap forward in terms of the evolution of agency.
Because now you've got multiple cells working together. So you need some way to coordinate all those individual actions towards a common goal.
Precisely. You can't just have cells acting independently. You need a way to orchestrate their behavior, and that's what led to the evolution of nervous systems.
And I'm guessing those early nervous systems were pretty simple, right?
Oh yeah, at first they were quite rudimentary, like basic nerve nets, but over time they evolved into intricate networks connecting sensory structures to muscles and creating, layers of interneurons in between.
And that allowed for more complex behavior.
Well, it was about much more than that. With these increasingly complex nervous systems, the meaning of signals started to become disconnected from immediate action.
What do you mean?
Well, instead of just triggering a direct response, signals could be processed internally. And this created a space for something we might call cognition.
So it's not just about reacting anymore. It's about interpreting, deriving meaning from those signals.
You got it. Signals start to have semantic content. They mean something to the organism beyond just their immediate physical effect. And this ability to represent information internally is crucial for the development of more complex forms of agency.
So the world is no longer just a collection of stimuli to react to. It's a place full of things that have meaning and significance.
Yes. And this is where things start to get really interesting, because as evolution continued, this ability to learn and adapt, it just becomes more and more sophisticated, paving the way for even more complex brains and behaviors.
Brain's cognition, internal models, it sounds like. We're getting closer to what makes us human. But we'll have to pick up that thread in our next part. It's going to be fascinating to see how we transitioned from those early brains to the incredible capabilities of the human mind.
I can't wait. You know, when life moved from those oceans onto land, that was
Oh yeah, a huge change.
a major turning point.
Yeah, like a whole new world opened up.
Absolutely. The sensory landscape just exploded, right? Suddenly you have all these new challenges, new opportunities.
Yeah, like all those land-based predators sneaking up on you. So what happened to brains as a result of this?
Well, senses like vision and hearing, those became way more important. Organisms could now perceive things from a distance.
Right, like they can see danger coming.
Exactly. And that meant they needed to anticipate, to think about the future in a way that, wasn't necessary before.
Makes sense. They couldn't just react to what was right in front of them anymore. They had to develop a way to predict, to plan.
Precisely. And that called for more sophisticated brains that could handle a lot more information, create internal maps of the environment.
So they could figure out where they were, where they needed to go.
Exactly. And they could use those maps to guide their actions. So it's a whole new level of complexity.
It sounds like evolution was pushing for a kind of intelligence that was more flexible, adaptable, able to keep up with a changing world.
Yeah, and this trend, it really accelerated with the arrival of mammals.
Oh, really? Mammals were doing something different.
They developed this even greater capacity for learning and adapting, which required, an even more complex control system.
Right, because all that new information needs to be managed somehow.
Exactly. So what's going on in their brains? Well, one of the key developments was the evolution of the neocortex.
The neocortex, that's the part of the brain that does all that higher level thinking, right? Like planning and decision making.
You got it. And in mammals, especially primates, the neocortex expanded significantly, gave them a real edge in terms of, cognitive flexibility.
So that's what allowed them to, solve more complex problems, come up with new strategies.
Exactly. And then in humans, the prefrontal cortex, that's part of the neocortex, became even more developed.
Oh, wow. So humans were doing something even more special with their brains.
This led to a pretty remarkable evolutionary leap. We developed the ability to have a model of our own minds.
Wait, a model of our own minds? That sounds pretty deep. What does that actually mean?
It means we can think about our own thoughts, we can have goals, desires, beliefs.
And we can question our own assumptions.
Yeah.
Like step back and analyze our own thinking.
Exactly. It's like having a mind within a mind. It allows us to operate on, abstract ideas in a way that no other animal can.
That's incredible. It's like we stepped outside of ourselves and became aware of our own internal processes.
You got it. And this ability for recursive thinking about thinking, that's a key part of what makes human consciousness so fascinating, maybe even mysterious, right?
Yeah, it definitely raises some big questions. Like, was it just biological evolution that led to this kind of consciousness? Or were there other factors involved?
Well, the book definitely suggests that language and culture played a crucial role.
Makes sense, right? Once you can communicate complex ideas, share knowledge, that has to have a huge impact on how we think.
Right. Thinkers like Daniel Dennett, Kevin Leland, and Cecilia Hayes, they argue that these cultural factors were essential.
So our ability to talk to each other, to build on each other's ideas, That might have been the key to unlocking the full potential of our minds.
Yeah, that's the idea. Language might have been the thing that allowed humans to move into what they call the cognitive niche.
The cognitive niche. What's that?
It's like we stumbled onto this incredibly powerful tool that allowed us to collaborate, learn from each other, transmit knowledge across generations.
So we don't have to reinvent the wheel every time.
Exactly. And then once we have language, every new idea, every innovation can build on what came before. And it creates this, self-amplifying cycle of cultural and cognitive evolution.
Wow, so the power of language might have been the missing piece. The thing that allowed us to develop abstract thought, creativity, all these things that set us apart.
It's a fascinating idea. And it's this capacity for abstract reasoning, for imagining possibilities, for creating things that have never existed before that leads us to that big question,
It's a big one, yeah.
Mm-hmm.
After this incredible journey through the evolution of agency, we finally get to tackle it head on. Do we have free will?
Well, maybe the answer isn't a simple yes or no.
Oh, here we go.
Right. Maybe we need to figure out what we even mean by free will before we can answer.
Okay. Define the terms before we try to solve the problem. I like it.
Exactly. Now, in philosophy, freedom is often defined as the ability to act, completely free from any prior causes whatsoever.
So like no constraints, no influences, just pure, unadulterated freedom.
Right. But if you think about it, that kind of absolute freedom, it doesn't really make sense in the context of who we are as individuals.
Wait, why not? Isn't that the whole point of free will, to be totally free?
It might seem that way, but consider this. We are who we are because of our past experiences, our memories, our knowledge.
Our values, our genetic predispositions, yeah.
Right. All of these things shape our choices.
But doesn't that mean we're trapped by our past? If our choices are just products of all that, how can we be free?
That's a great question, and it gets to the heart of it, right? See, to be completely free from any prior causes, that would mean acting randomly, with no reason or purpose.
Oh, I see what you mean. It would be like erasing everything that makes you, you.
Exactly. Our memories, knowledge, goals, even our, psychological quirks, those aren't limitations on freedom.
They're what make us who we are.
They're what allow us to act as agents in the world.
So our past isn't a cage. It's more like, a foundation we can build on.
That's a good way to put it.
But if absolute freedom isn't really possible, does that mean free will is just an illusion?
Well, the book suggests that maybe we need to move beyond this all-or-nothing view of free will.
Okay, so not just an on-off switch.
Right. Instead of asking if we have it or not, maybe we should be asking how much we have.
Degrees of freedom. Interesting.
Yeah, this view, it aligns more with our actual experience, right? We know we make choices, but we also know those choices are influenced by stuff.
Right, so we're not completely free in that absolute sense, but we're not just puppets either.
Exactly, we're somewhere in between.
Navigating a complex landscape of influences.
And making choices within that context.
Okay, that makes sense. But what about the argument that everything is predetermined? That our choices are just the inevitable outcome of, like, a chain of events that started with the Big Bang?
Ah, the classic determinism argument.
Yeah, doesn't that just blow the whole idea of free will out of the water? Even if it's just degrees of freedom.
Well, the book argues that this idea of a totally predetermined universe, it's just not supported by what we know about physics.
Really? But if every effect has a cause, doesn't that mean the future's already set?
It might seem that way if you think of the universe as like a giant clockwork machine. But modern physics, especially quantum physics, it suggests that there's a fundamental level of indeterminacy at play.
Indeterminacy, so like a bit of randomness.
In a way, yes. Not that everything is random, but there's a certain amount of wiggle room,
So we can't predict the future perfectly.
Exactly. And this indeterminacy, this is what creates the space for genuine choice to influence how things unfold.
So it's not all set in stone, but it's not completely random either. It's somewhere in between. And that's where free will operates.
You got it. And in living organisms, this capacity for choice is shaped by that drive to persist, to thrive, to make something of themselves in the world, right? We're driven by goals, by meaning and purpose.
So even our most basic actions, they're guided by something deeper than just cause and effect.
It's fascinating, isn't it? And as we evolved, this sense of purpose became increasingly intertwined with our ability to, think consciously, make decisions.
So we're not just reacting, we're acting with intention.
Exactly. We have a sense of why we're doing what we're doing. And in humans, this is amplified by our ability to reflect on our motivations, to question our beliefs, to shape our own values and goals.
Okay, so we've established that we have at least some degree of freedom. We're not just robots following a program. But what about genetics, psychology, neurology? Don't those fields suggest that our choices are ultimately determined by our biology?
Oh, absolutely. The book acknowledges that genes and brain development influence our predispositions, and that's undeniable. We inherit certain tendencies, ways of thinking, and those can have a big impact on our lives, but they don't dictate our behavior.
So we're not just slaves to our genes.
Right. They provide a foundation, but we have this incredible capacity for conscious control.
We can learn, we can adapt, we can make choices that go against our initial inclinations.
That's what makes us human, and that's where things get really interesting when we start talking about moral responsibility.
So if we have this ability to choose, does that mean we're responsible for our choices?
Big question, right? And it has huge implications for how we think about justice, punishment, rehabilitation.
Absolutely. And I think it's a perfect place to pick up in our next part. We've covered so much ground already, from the very beginnings of agency to the complexities of free will.
It's been quite a journey.
Last time, we talked about how even the simplest organisms have this drive to persist, this spark of agency that evolved into more complex forms over time.
And then with humans, it's like that spark turned into a flame. We have this incredible capacity for self-awareness, for making conscious decisions.
Right, and that brings us back to this question of responsibility. If we have these degrees of freedom, as we talked about, how do we reconcile that with the fact that we hold people accountable for their actions?
Yeah, it's a tough one, right? But the book makes the argument that even with all the advances in science, all the things we've learned about the brain, nothing really changes the basic idea that we can control our actions.
So we're not off the hook just because our brains are complex.
Nope. We still have that capacity for rational control. We can think things through, weigh our options, and make a choice.
And I guess that's reflected in how we learn, right? Like,
Right.
we respond to praise and blame, rewards and punishments. Those things shape our behavior.
Exactly. Think about social emotions like pride and guilt. Those are powerful motivators. We want to be seen as good, as responsible.
So we try to do the right thing. It's like those emotions are a kind of internal feedback system.
Yeah. And we learn from our mistakes. We try to get better. We even develop what Daniel Dennett calls meta-responsibility.
Meta-responsibility. That sounds intense. What is that?
It's like this higher level ability to reflect on our own self-control. We can actually work on being more responsible.
So it's like taking responsibility for being responsible. That's a pretty cool concept.
It is. But while responsibility might be a constant, our growing understanding of the brain does raise some interesting questions about how we judge legal responsibility.
Oh yeah, that's a big one. We're seeing more and more neuroscience being used in courtrooms these days.
And that can be helpful. But we have to be careful not to overinterpret the data.
Right, like just because a brain scan shows something doesn't mean we can jump to conclusions about a person's guilt or innocence.
Exactly. We're still early in our understanding of the brain, and there's a danger of reducing complex behavior to simple biological explanations.
Yeah, it's like saying, oh, this part of the brain lights up, so this person must be a criminal.
Right. We've been down that road before with things like phrenology, remember? Trying to judge people's character based on the shape of their skull.
Or physiognomy, where they did the same thing with facial features. Totally discredited ideas, but it feels like we could make those same mistakes with neuroscience if we're not careful.
Absolutely. Brain scans and genetic findings can be valuable, but we can't reduce people to just data points. We need to look at the whole picture. Their history, their environment, the specific circumstances.
It's a big ethical challenge. How do we balance understanding the brain with still holding individuals accountable?
It's a tough one, but it's a conversation we need to have. Some people think neuroscience could actually lead to better rehabilitation programs, tailoring treatment to individuals based on their brain activity.
That sounds promising. But I can also see it being misused, like trying to predict whether a child will become a criminal based on their brain scan or something.
It's a scary thought, and it highlights why we need to be so careful about how we use this knowledge. The stakes are really high.
Okay, so we've gone from the evolution of agency to the complexities of free will and the challenges of applying all this to the legal system. That's a lot.
It is. But there's one more idea I wanted to touch on from the book. process philosophy.
Oh, yeah, that was interesting. It's like a whole different way of looking at the world, right?
Exactly. It's
Uh,
about seeing reality as a dynamic web of processes, everything constantly changing and interconnected, not just a bunch of static objects.
so more like a river than a photograph.
Perfect analogy. And it really fits with what we know about living things. They're not just things. They're processes unfolding through time.
So even something like a rock, which seems pretty solid and unchanging, is actually a process happening just really, really slowly.
Exactly. And what's fascinating is that this idea is popping up in physics too, with some physicists seeing even space and time as emergent properties of relationships.
So this old philosophical idea is finding new life in modern science.
It is, and it gives us a really powerful way to understand how complex and interconnected reality is.
Including ourselves as agents within that reality.
Exactly.
Okay, one last thought before we wrap up. The book we've been talking about, it presents a pretty utilitarian view of how brains evolved. Like everything is about survival and reproduction.
Yeah.
But it also hints at something more, something uniquely human.
You're talking about transcendence, right? The idea that our minds can go beyond their original purpose.
Yes, like we create art, music, literature, science, all these amazing things that seem to go way beyond just surviving.
It's like our brains were shaped by evolution to help us deal with a tough world, but we took those same brains and did something completely unexpected with them.
We built civilizations, explored space, asked the big questions about the universe, and we did it together, sharing ideas and building on each other's knowledge.
Exactly. It's the most inspiring part of human agency. We can go beyond our biology, create meaning and purpose that's bigger than just survival.
So we're rooted in biology, but we can also reach beyond those roots. We can shape our own future, maybe even the future of our planet.
It's a powerful thought.
It really is. And it reminds us that the journey of understanding ourselves, our place in the universe, it's not over yet. Well, that brings us to the end of our deep dive into agency and free will. Thanks for joining us.
It's been a pleasure.
It's been an incredible conversation. We started with those first single-celled organisms and traced this incredible journey through billions of years of evolution. We talked about what it means to be an agent, the complexities of free will, and even how our understanding of the brain is changing our legal system.
Lots to think about.
It really is. And as always, there's so much more to explore. So keep those minds curious, keep asking those big questions, and we'll